A modern vehicle is parked in a quiet driveway for the night. All day it ran without issue, and now, with the engine switched off, it sits undisturbed in the dark. But the next morning, the driver turns the ignition and is met by an array of warning icons across the dashboard. The instrument cluster reports simultaneous failures in the engine management, the anti-lock braking system, and the airbag safety module. This setup shouldn't be possible. Automotive engineering relies on the isolation of these systems into separate, independent computer networks that do not share operational pathways. At MVS Technical, the mechanics find that their digital diagnostic tools are hitting a dead end. The computers report errors, but cannot explain why 3 separate networks crashed at the same time. Solving this requires a shift from software analysis to a physical teardown of the car's internal architecture. When separate, isolated systems fail together without a common electrical fault, it suggests the root cause is something the computer cannot see. The investigation begins under the chassis, tracking the engine faults toward the exhaust system. Attached to the metallic exhaust pipe is an oxygen sensor. Its wire harness has been severed, leaving the ends frayed and disconnected. Severing this line prevents the engine computer from monitoring exhaust data, which explains the initial check engine light. The technicians then move to the rear wheel wells to locate the source of the braking system failure. Near the rear suspension spring, the colored wires for the wheel speed sensors are hanging unattached, stripped of their protective casing. Without these signals, the vehicle loses its anti-lock braking and traction control, making the car unstable during an emergency stop. These specific damage patterns point to a biological cause. Rodents have teeth that never stop growing, and they use the residual heat of a parked engine bay as a workshop to file them down on whatever materials are available. The car's underbelly provided a warm environment where a rodent could disable the vehicle's primary driving and stopping systems in a single night. The investigation moves into the interior cabin to find why the airbag system has also gone offline. Accessing the interior's central wiring requires a total disassembly of the dashboard and the removal of the center console. Removing the trim reveals the bare metal floor pan hidden beneath the carpet. On the black metal framework, there are piles of shredded tan foam padding that have been torn from the car's insulation. This debris confirms nesting behavior. The intruder wasn't just passing through, it was actively building a habitat inside the cabin. Next to this nest is the yellow airbag control module. The wires entering the black connector are chewed through, exposing the copper cores. By destroying these data lines, the rodent disabled the deployment mechanism designed to protect the driver during a collision. What began as a search for warmth resulted in a deep infiltration, placing a physical hazard directly against the vehicle's safety computers. Modern cars are essentially advanced computer networks wrapped in thousands of feet of exposed wiring. This cluster of yellow and black wires pulled through a rubber grommet shows how vulnerable these critical communication lines are to damage. Finding and patching each breach is a manual process software cannot assist with. Every wire must be checked and insulated by hand. Millions of dollars in safety engineering can be bypassed by the simple instinct of a single mouse. For the owner, this results in a bill for weeks of specialized labor and the physical replacement of the vehicle's wiring harnesses. Drivers should monitor their parking environments. A sudden array of dashboard lights on a cold morning is often the first sign of a hidden infestation.